I'm Mr. Tapia, and thank you for watching my video. This is part 2 on balancing chemical equations, and if you'll notice, I used the same one from the part 1. And so I thought in this video I would show a different way how to solve chemical equations. As far as I could tell, I did not see this way online anywhere, so this is really only the way that I would do it. So the first thing we're going to do is we need to split the products from the reactants. And so to do that, we'll just draw a little line here. Now, the whole point of balancing chemical equations, like I said in the first video, is pretty much that what we have in the beginning, we have in the end. The law of conservation of mass states that nothing is created or destroyed, only transferred. So we will still have the same number of nitrogen atoms at the end as we have in the beginning. And likewise, we will still have the same number of hydrogen atoms in the beginning and the end as well. So, let's get started. So the first thing that we will do is we will write it nitrogen, okay, which is right here. And we will write, as you can see, it starts here at 2. So if we put a 1 here, it's 1 times 2, and so we start out with 2. If we took that 1 away, real quick, okay, and we put a 2 there, it would be 2 times 2, which is 4. And so as you can see, nitrogen moves in sets of 2, and so we would go from 2 to 4 to 6 to 8 to 10. Now the next element that we have hydrogen, and so as you can see, we'll put hydrogen here, and as you can see, it, just like the nitrogen, will move in sets of 2, because as you can see, there's a 2 right there. And so we will go 2, 4, 6, 8, and 10. Now we'll go to the other side, which is where the reactants are. And we will go ahead and put all of this in 1, and we are just putting the elements. So we have N and we have H. As you can see, N doesn't have any numbers next to it, and so it will go in sets of 1. So if we put a 1 here, we have 1 nitrogen. If we put 2, we put 2. So it just goes in sets of 1. So 1, 2, 3, 4, 5, about 6. Okay, now the hydrogen is the one that would probably give most people the most trouble. As you can see, it has a 3 here, and so as you saw from the two 2's on the left side, it will go in sets of 3. So if we added a 1 here, 1 times 3 would be 3. And if we had a 2 here, it would be 2 times that 3. So 2 times 3 would be 6. And since essentially we just move in sets of 3, so 3 to 6 to 9 to 12 to 15 to 18. Okay, so the general rule for solving chemical equations, at least my rule, is to always go for the biggest one first. And once we get done with the biggest one, we will just move to the next one. And that can be any of these out there. So let's talk about the biggest one. So first, let's look at nitrogen. So let's say that we had 1 molecule of nitrogen. We'd have one nitrogen and 3 hydrogen. Well, is there a 1? So this one. Is there 1 nitrogen? As you can see, there is no place here that there can be 1 nitrogen. Is there 3 hydrogens? Well, as you can see, there's nowhere here that there's a 3. And so this one cannot be used. That moves us down to the next one. So we have 2 and 6. So, is there a 2 nitrogens? Well, as you can see, there's a 2 right there. Is there a 6 hydrogens? 6 hydrogens. Well, as you can see, there's 1 right here. Now, as you can see where we are, we have essentially found this side over here. So we know that this nitrogen here that has 2, and this one that has 6 hydrogens, we know that we can line them up, and we can have 2 nitrogens on this side and 6 hydrogens on this side. The next step is pretty easy. We're basically just going to number them down. So we have 1 down, okay, and that's this number. We have 1, 2, 3, and so that's this number. And on this side we have 1, 2, and so that is this number. So we went 1 down, 3 down, and 2 down. As you can see, we have 1 times the 2 here, that equals 2. And that balances with this side. We have 2 times the n, that's 2 times the 1, which is 2. And as you can see, we have 3 times the 2 hydrogens here, which is 6, and we have 2 times the 3, which is also 6. So this is a completely balanced chemical equation. I hope you enjoyed my video, and thank you for watching.